Now our topic is production of rotating magnetic field and the development of torque in three-phase induction motor. First let me explain about how to prepare rotating magnetic field. You know how to prepare electromagnet by taking iron piece wounded with wire and give supply. If you given DC supply, unidirectional magnets will exist. If I have given AC supply, bidirectional alternating magnetic field will exist. Means one part of iron piece behaves as north, next half cycle that part behaves as south pole. That's why poles will changes alternatively. That's example for alternating magnetic field. If I give DC supply, so north pole to south pole always flux travels. So it is comes under static magnetic field, steady state magnet. It is not rotating, stationary magnetic field you can call it. Now to get rotational magnetic field, if I rotated permanent magnet or electromagnet with a DC supply, if I rotate physically by giving mechanical energy, it comes under rotating magnetic field. It is one case. Means rotating magnetic field we discuss with two cases. Case 1, physical rotation of magnets by taking any magnet with rotating, and another by giving n phase supply to the iron core. N phase supply means n number of windings. With that also we can prepare rotating magnetic field. This type of rotating magnetic field is used in three-phase induction motor. Means iron piece wounded with wires. One wire means single phase. With the single phase you will get an alternating magnetic field only. It is not possible to prepare rotating magnetic field. So minimum number of phases required are 2. If number of phases are more than 3, we know how to displace each and every phase by 360 by n, by using formula 360 by n. But for two phase we have to place each winding with 90 degrees. As per our assumption, 360 by 2 means 180 degrees. If you place 180 degrees, again same poles will exist, like alternating pole flux, alternating poles, north pole, south pole, north pole, south pole. Which direction magnet rotation we can't identify. That's why mostly we have to place each phase displaced with 90 degrees. We will see with the working principle of induction motor this phenomena. Now let me explain about rotating magnetic field in three-phase induction motors. So we know three-phase balance supply. Each phase is displaced with 120 degrees. Now here case 1, case 2 I explained here how to get rotation forces. See there explanation for case 2 here. Three-phase supply waveform if you observed here, because of current in three-phase supply, remember current always flows from one phase to other phase only. Means one phase which is having more positive, from that phase current start flows, and which phase is having more negative, to that phase current will flows, right? Which is having more positive, current starts, and which is having more negative, current ends. That's why three phase scheme always we define phase to phase voltage, which is called line to line voltage. If there is neutral, we can define phase voltage also. Now see here at stage 1, because of R phase current is flowing. In stage 1, first from first 60 degrees R phase to Y phase current is flowing. Next 60 degrees R phase to B phase current is flowing. Whatever may be, at case 1, stage 1 you observe. From R phase is having more positive, means because of R phase current starts flows, and Y and B are negative, they are having negative. So current ends in Y phase at some time and B phase sometime. That's why R phase I can represent here cross mark, Y and B I can represent dot marks, if I assumed R phase as cross entry current. Similarly Y phase, B phase also at stage 2, stage 3, those are having more positive, remaining and down are more negative. If any phase current is entering into one terminal, means another phase current will leaves. Another end current will leaves. Now see at stage here in this diagram I represented one electromagnet iron piece wounded with DC supply, which is north pole and which is south pole. To identify, we are going to using here right hand thumb rule. In that right hand thumb rule, I said I said as we discussed, we can apply in two ways. For concentric winding, current directions, four fingers other than thumb of your right hand, four fingers if represented current direction, then thumb indicates north pole polarity. And no doubt bottom one is south pole. Like that we use right hand thumb rule for concentric winding, but for distributor winding is different. There we represent current direction with the thumb, then the four fingers represents flux direction. In that, see there in that figure, iron piece part which is giving flux, it is working as north, which is giving flux to the air gap is working as is acting as north pole, and which is taking flux is acting as south pole. See their diagram, arrow marks I represented here very clearly. Iron piece part which is giving flux. By using this we can represent poles polarities in distributed windings. Now let I am assuming here three phase two pole machine, induction motor, two pole, three phase two pole machine. Here we are going to studying about only magnetic field concept. That's why I took only stator part. Stator part means iron piece wounded with wire. So to the stator we will give three phase AC supply. Three phase means there we provided three windings: R phase, Y phase, B phase. R phase with R and R dash, Y dash, B dash. Now I place each winding with 120 degrees with each other. See three cases I am going to explain. You come to first stage. What I said, R phase is having more positive means R cross R dash is dot. At that time YB, you see the waveforms if you are having doubts. YB negative. That's why Y dot B negative I represented. If Y negative, Y dot means Y dash cross. Similarly, B dot means B dot means B dash cross. So currents are flowing. Now I grouped these three windings into two groups. R, B dash, Y dash as one group because those are having cross. B, R dash, Y dot, those are I consider those as one group. Now see iron piece wounded with wire, currents are flowing. No doubt it works as magnet. So which is north pole and which is south pole we identify by using right hand thumb rule. Here thumb, if you represented current direction, then remaining four fingers of your right hand will represent north pole, poles polarity, which is north pole, which is south pole. Means the iron piece, what I said, iron piece part which is giving flux inside the ring you observe, that is called air gap. The iron piece part which is giving flux to the air gap will act as north pole. If you observe, if you represent the thumb in the direction of current entering at cross, then north if you observe this video, right side ring will act as north pole if you want to apply thumb inside. If you want to here down group, dot means come up, you represent a thumb towards you, then at that time also right part always giving flux to air gap. That's why that right part of iron piece behaves as north pole and left part of iron piece behaves as south pole. Similarly at stage 2, same thing you observe there are Y is cross, Y dash dot, R, B are dots, so remain those ends are opposite cross. There also you form two groups, currents flowing. Again you apply right hand thumb rule, north pole south pole form. Carefully, you apply very carefully right hand thumb rule. At stage 3, there also see there groups. Here Y face, here B face is cross, Y or dot. So those other ends are opposite. Now there also you can get north pole south pole. Means if you given three phase AC, it applies to the stator core. Stator core means see there here I am representing here stator core. If you given three phase AC supply, this type one time certain period north pole south pole will forms like this as in stage 1, and the next immediately after some time poles will rotate, comes to this stage, and at the stage 3 poles will come to this stage, again poles will come to as like stage 1, like this poles will rotate continuously. So if you observe here stage 1 2 3 frequently sequentially, in which state we can say magnets are rotating in clockwise direction, we can say magnets are rotating in clockwise direction. This is called rotating magnetic field. See what I explained, each and every point I wrote here at stage 1. Similarly, just reverse to similar to stage 2. Now here this is called rotating magnetic field. To develop a torque, I am going to introducing in that rotating magnetic field conductor. Conductor means what? Iron piece wounded with wires. Conductor, iron piece wounded with wire. Mostly conductors are provided with closed loop. Remember, provided with closed loop must. Why? Because if there is no current, if EMF will develop by according to Faraday's law, if there is no closed path, no current will flow. If no current is flowing, you want to get another magnet. We discussed already, to develop torque we need two magnets displaced with certain distance, not in phase. Right now, see there conductor I introduced here. We discussed already Faraday's law. So inside the conductor, so many conductors are there inside the armature core. So in many all are distributed running. The conductors which are there in the flux region, there only EMF develops according to Faraday's law. That's why the stage 1 you see the one conductor only I took. So this conductor is cutting by the flux. So in that conductors only EMF is developing. So EMF develops. After developing induced EMF, if you provide closed path, current will flows. To know those current directions, again we have to use Fleming's right hand rule here. Remember Fleming's right hand rule. Fleming's right hand rule. What are the inputs? Conductor motion, flux direction. But here conductor is moving or not moving? Conductor is stationary. What magnetic field is? Rotating. Means we can say with respect to the magnetic field, conductor is moving. If magnetic field is rotating in clockwise, means conductor moves anti-clockwise direction with respect to the magnetic field. Means here magnetic field is rotating clockwise direction as we discussed. That's why conductor rotates in anti-clockwise direction. That's why I represented, see there one part of the conductor dot represented above, upward. Now I can say that part of conductor is moving upward, you represent with the right hand thumb, and flux is moving how? From if you watch video, from your right hand to left hand flux is moving. So represent as your forefinger in the direction of flux. Then middle finger is represented which direction? Towards you. Towards you means dot. Same concept you apply there also. You can get cross. Now you got north pole, south. You got now currents are flowing through the conductors. Iron core wounded with wires. Current is flowing means this also will work as a magnet. Again, to identify that magnet which is north pole, south pole, we use right hand thumb rule. This also comes under distributed winding. So you represent thumb in the direction of current, any direction, in cross entering, dot leaving, your wish. Then bottom one will act as north pole and top one will act as south pole. Now see the magnets there. Stator north, rotor north, you observe both will repels with each other. Stator is fixed with bolts and nuts with rigid body. Rotor is provided free to rotate. So north repels, north south attracts. So which direction conductor moves? Conductor also moves in clockwise direction as the direction in rotating magnetic field. Same you observe stage 2. There also magnets are forming where in that only that conductor inside the conductor only I considered. At stage 3 also this conductor only I consider. See, observe here how conductors are also moving in the clockwise direction. So this rotational forces are called torque. These rotational forces are called torque. Now by seeing magnets we are going to saying which direction motor or conductor is moving. But technically we can't see the magnets. You can see the magnet physically. Technically we can represent the motion of the conductor with Fleming's left hand rule. See there here right hand thumb rule we are applying, right? Fleming's right hand rule we are applying, Fleming's left hand rule we are applying. See now what you observe here, north repelling you observe means conductor is moving clockwise. If you want to apply your Fleming's left hand rule to the left hand rule, what are the inputs? Flux direction and a current. Flux direction and a current. Then thumb indicates conductor motion. See stage 1 main field flux, how it is moving from your mobile right hand to left hand. So it represent with the left hand only, represent forefinger from north pole to south pole. Take your right side part of the conductor, dot part means currents are coming out. So flux is moving from north pole to south pole, currents are coming out. Then thumb is moving which direction? Downward direction. Downward. What I took is at stage 1 rightmost conductor dot part I took. If you want you can take cross part. Which direction flux is moving from right hand to your right hand to left hand, represent your left hand only, forefinger represent north pole to south pole. Then currents are here what? Entering means you represent dot. Then thumb indicates which direction? Upward direction. You can represent upward means conductor is moving upward, means it is moving clockwise direction. Similarly same you apply at stage 2, stage 3. So this is called torque, means development of rotating magnetic field and torque. This phenomena we are going to studying in induction motor, development of production of rotating magnetic field and the development of torque. Okay, in the next session we will see construction of induction motors. Thank you very much.